In this video, we are going to look at the differentiation of power functions, at times known as the differentiation of constants to variable powers. Let's consider this question. The first thing to observe is that an integer, here 3, is raising x up. X is at the power. To find the derivative of this form of function, step number 1, take the natural log of both sides. Recall that the natural log of x is the same thing as log x with exponential base. Also recall that an integer to the power of x is the same as exponential multiplied by natural log that integer to the power of x. You can bring this x to the front of the natural log and you end up having this. That is 3 to the power of x can be rewritten as exponential the natural log of 3 to the power of x, and can be rewritten as exponential x multiply the natural log of 3. Recall that exponential multiplied by natural log is equal to 1, just as exponential in x is equal to x. Remember, here there is a 1. This is one method of approaching the problem. But in this video, I'm going to use taking the natural log of both sides. Next, we're going to take the natural log of both sides, which is step number 1. Here, remember that the base of this log is of base e, which is the natural log. I can equally rewrite this for this natural log, or this for this. Both are the same. Always remember that the natural log of x is the same thing as log x of base e. Next, recall that the natural log of is the same thing as a, the natural log of b. That is, if you have the natural log of 3 to the power of x, it's the same as x multiply the natural log of 3. That is, this x at the power will come to the back of the natural log. We are going to apply this to the question. Next, this will now become this. Next, we are going to differentiate both sides separately. On this side, I'm going to apply implicit differentiation, while on this side, I'm going to apply product rule. Next, differentiate the natural log of y, and you have 1 over y. However, because you differentiated y and not x, the consequences is that you are going to multiply it with the y, the x, according to the rule of implicit differentiation. Recall that when you differentiate the natural log of x, you are going to have 1 over x, and when you differentiate the natural log of y, 1 over y. However, for y, you are going to multiply it with the y over the x. This is the difference between when you differentiate the natural log of x and the natural log of y, according to implicit differentiation rule. Next, we're going to differentiate this using product rule. Remember, x is multiplying natural log of 3. Next, keep x constant. Next, differentiate the natural log of 3. 3 is a constant, and when you differentiate the natural log of a constant, you're going to get 0. Next, we're going to put a plus according to the product rule formula. Next, we are going to keep the natural log of 3 constant. Next, we are going to differentiate x. Differentiate x, you're going to get 1. Next, x multiplied by 0 will cancel out because it's 0. And 1 multiply the natural log of 3 will return the natural log of 3. Next, I can rewrite this to become this. Both are the same. dy dx is an entity. Next, I will take y across the equal sign to multiply the natural log of 3. Next, we are going to replace the value of y from the given question. Replacing the value of y, this is our dy dx. From the options, our answer is B. Remember that this option is the same as this. Alternatively, we can apply a shortcut approach. From the basic derivative table, when we differentiate an integer to the power of x, it's going to give you that integer to the power of x multiplied by the natural log of that integer. With this in mind, then the dy dx is, I will bring this down. Next, I will now write the natural log of that integer, excluding the x. And this is our dy dx, which is same as we obtained earlier. Let's find the derivative of this function. Step number 1, take the natural log of both sides. Next, the x at this power. Next, let's differentiate the natural log of y, and we have 1 over y. However, because you differentiated y and not x, you are going to multiply it with dy dx according to the rule of implicit differentiation. Next, x is multiplying natural log of 2. Hence, for multiplying functions, we are going to apply product rule. Next, we are going to keep x constant. Next, let's differentiate the natural log of 2. And because this is a constant, the natural log of any constant is 0. Next, we are going to put a plus according to the rule of product functions. Next, we are going to keep the natural log of 2 constant. Next, we are going to differentiate x. When you differentiate x, you are going to get 1. Remember, the knowledge of these rules will help you to solve this problem. Next, I can rewrite this to become this, because dy dx is just one entity. Next, the y at the denominator will move over to the other side to multiply the natural log of 2. Next, replace the value of y from the given question, which is 2 to the power of x. And this is our dy dx. Alternatively, using the shortcut approach, the basic derivative table, when you differentiate an integer to the power of x, it will give you that integer to the power of x multiplied by the natural log of that integer. Applying this concept to this question, the dy dx is bring down the given integer to the power of x. Here we have 2 to the power of x. Next, multiply it with natural log of that integer without the x. And this is our dy dx, which is the same answer as we obtained earlier. From the options, our answer is D. Remember, this and this are the same. Next, let's find the derivative of this function. When you solve correctly, this is our dy dx, which is the same as this. Also, from the basic derivative table, when you differentiate a constant to the power of x, it's going to give you back that constant to the power of x, multiply the natural log of that constant. Applying this to this question, 4 to the power of x will come back. However, we'll multiply it with the natural log of 4, which you can obtain in few seconds. From the options, our answer is B. Remember, this is the same as this. Both are the same. In conclusion, in the differentiation of a constant, let's differentiate 2 to the power of x. You will have 2 to the power of x laying 2. Next, let's differentiate 6 to the power of x. And you will have 6 to the power of x, the natural log of 6. Let's differentiate 7 to the power of x. And you will have 7 to the power of x multiplied by the natural log of 7. Next, let's differentiate 15 to the power of x. And we're going to have 15 to the power of x multiply ln 15. Ln is a short form of writing natural logarithm. You can observe in this video I excluded negative integers. Integers in this form. The derivative of this form of function will be considered in the next video. This is calculus. In the next video, we are going to consider the derivatives of negative power functions. These are recommended video topics in differentiation, and also some suggested video topics in integration, including their applications, including PRECALCULUS video topics. To locate all these videos, follow the link on the screen. I will see you in the next video.